Any questions on that? How to do that, even if you're just finishing it up?
No, not really.
Okay. All right, so next question here, it says to state the association. Snip that
Yeah.
in here. So what they're looking for is something like this, as blank, and then the word either increase or decrease. But usually it's increases. Blank increases, blank, and then you have to choose what's going on over here. So for example, going back to this last picture, do you see that it sort of generally trends up and to the right?
Yeah, I see that.
Okay, so we would say as age increases, as we go right, the TV watched, and then you have to choose here, does it go up or down? Well, it increases.
Yeah.
And it's kind of a fill in the blank situation. There are other words we could use, but based on what I'm seeing here, you don't need to get any more in depth than this.
Okay.
Is that okay?
Yeah,
Or
that's okay.
this is a part of the course where they're previewing something you might see in another class at another time.
Okay.
And so if you like it, you get to see it again. If you don't like it, know that it's going to be done whenever this test is over.
Okay, cool.
Okay, it says to draw a line of best fit through the data points 2020, 30, 25. So I got to go back and identify those. 2020 is right here, and then 30, 25 is right there, which on my screen sometimes a little hard, but it's basically I'm crossing through like that.
Okay.
So they're expecting that. Now, it does not go further left than this. And that's important because age 0 is what birth, we'll say. Like you wouldn't want to show it going past this because we don't have a negative age. Going right here is a little bit, you don't want to say it goes on forever because we know people don't live forever. Sometimes instructors are difficult with that, but you want to get a data point through there. Now the equation of the line, this is like review. There's y equals mx plus b, y minus y1 equals your slope, x minus x1, and then there's ax plus by equals c. So your instructor is not specifying which one, which means you get to choose. And we're going to choose the first one because that's probably the most common here. Plus, it's kind of telling you, hey, it's already solved for y.
Yeah.
So this first one is called slope intercept form,
Okay.
and we need the slope, and then we need the intercept.
Okay.
So we get the slope from these two data points. The slope is y2 minus y1, x2 minus x1. And in terms of our data points, that's x1, y1, x2, y2. So we got 25 minus 20 over 30 minus 20, 5 over 10, or 1/2.
Okay. So they equal the same thing, 5 over 10 and 1/2, right?
Yes.
Yeah, okay.
All right, so then the next step here is to write the equation. So it's y equals 1/2 x plus b. And then to solve for b, we need an x and a y. So let's just use this first data point. 20 is the y value, 20 is the x value. 20 equals 1/2 of 20, which is 10. Subtract 10 from both sides, and b equals 10. That goes back to this line here, y equals 1/2 x plus 10. So this is your final answer. This is your equation
B
here.
equals 10.
Yeah, b is 10, and you put it back into the original. So 1/2 x plus 10. Let me know when you get all that down, and we'll move on to part D.
All right, I got it.
Okay, so notice that X is the age of the person, and that's
Yeah.
consistent with this here. Question D is a question that says, hey, use your equation and see if it makes sense for another situation. And that other situation here is 66-year-old. That means X is 66. Your equation you just came up with 1/2 X plus 10.
Yeah.
You're putting 66 in for X.
Oh, okay.
So that's Y equals 1/2 times 66 plus 10. So 1/2 of 66 is 33 plus 10 is 43. And that's the number of hours watched that we would expect.
Oh, you want? Oh my gosh, sorry. I didn't know you wanted me to answer that.
Yeah.
That's really my bad.
Let me know when you're ready to move on to part E.
Okay, I'm ready. Yeah.
Great. So part E says, what does the slope of the line of best fit represent? And really, I mean, this is what they're really asking is this like interpret question.
Okay.
And you need to write a sentence. That's what they're really saying. They should just say, write a sentence to explain what the meaning of the slope is. And you'd be like, okay, I know what to do. So to do this, you need the units of Y, and then you need the units of X. So you've got that paper in front of you.
Yeah.
What are the units of X? What does X stand for?
X stands for the bottom, I think, or the remainder.
We're looking at the table in the top left. What is the table? What did we identify as X? Which column?
E on the table. Wait, what do you mean table? Let's see the table.
Right next to question 1, there's a table.
Oh, the age and the TV.
Yes. So which
Okay, yeah.
one is the X?
X is the bottom of the.
Which column?
Oh, TV watched per week.
Okay. Did you write this down when I started out and said, let's call
No, I
X?
didn't write those X and Y.
Okay. But you did write, you labeled the,
Yeah, I labeled that stuff. That's what I said right there.
okay.
But,
All right. So what are the units of X? What does X stand for?
Age
In years. So it's the units, it is age, but we measure it in years.
Yeah.
What are the units of Y? Why is TV watched, but what are the units of it?
The hours.
Hours. Okay, so now we can answer this question.
Yeah.
Okay, the slope is, okay, and it's fill in the blank. Okay, and these are the units of Y. Okay, which is hours of TV watched per, and this is the units of X. So what are the units of X?
The units of X are the age in years.
So just the years.
Oh, yeah.
So the slope is the hours of TV watched per year. It's not a perfect translation, but if you just fill in the blank, like I imagine you get a test where it's just, it gives you a different scenario. If you can remember that it's units of y per unit of x, just like we wrote here, you can answer this on your own at any time.
Okay.
All right, so I'm ready to move on to 2A, but let
Yeah,
me know
that's
when you
good.
get all that
I'm
down.
ready to move on.
Great. Okay. All right, a jar contains 5 blue marbles, 6 yellow marbles, and 4 green marbles. Okay, I don't know why they always choose these marble problems, but they're pretty good, I guess, for trying to understand. But there's a jar with, if you can imagine, 5 blue, 6 yellow, and 4 green. This means this thing over here next to it says what is it? It's asking you, what is the probability of selecting a yellow marble?
It is high.
Yes, but it's an actual numerical value. And to do it, it's the number of yellow divided by the total.
Oh.
So it's the number of yellow, which is 6, and the total
Mhm.
is 5 plus 6 plus 4. 6 over 15. And then you do have to reduce that.
Okay.
So they're both divisible by 3. So that's 2 over 5. Now, if you want to, and if your instructor kind of like led you down this path, like you can convert this to a decimal, but these are both the same. These are both
Oh, okay.
correct.
Yeah, I don't think it matters to her.
No, and it shouldn't. But sometimes there's a comfort level with that. So you notice I made kind of a jar. Really, it's just it's just a box, open box. I like to label it this way somehow, that like I don't like to actually like draw the individual marbles. You just need to somehow symbolize that there's something in there.
Okay.
Okay, part B. What is the probability of choosing a yellow marble? Okay, which we actually just did. So choosing a yellow marble, not replacing it. So that means you don't put it back in the jar, and then choosing a blue marble. So is the scenario clear? You pull it, you actually get a yellow out, but then you don't put it back, and then you pull a blue out.
Mm-hmm.
Is that that's, I mean, if that's not clear, the scenario that is important, because this whole idea of whether you replace or don't replace does matter. So here we go. You've got 5 blue again, 6 yellow, and 4 green.
And then you divide it all by.
So so we got to do this in pieces. So like right there is first piece, and it's the same as before. The yellow is the number of yellow divided by the total.
Yeah.
So there are 6 yellow over 15.
Yeah.
Times. Now, when we don't replace it, what does the total go down to? If you take a yellow out, 1 yellow out, how many yellows are left over?
There are 63.
There's 6 yellows in there now, and then you take 1 out. How many are?
Oh, I thought. Oh my gosh. 5.
5. So your new total this time, this is your new total, is 5 plus 5 plus 4. It has to go down by 1 because you took 1 out. And then we want the number of blue. So there's 5 blue still remaining.
Yeah.
Okay, so probability is always the number that you care about, like in this case, blue or yellow over the total. The total could change. So this is 6 over 15 times 5 over 14. And the mistake here is to not try to reduce a little bit. Like 5 and 15 are both divisible by 5. 6 goes into 3, or 3 goes into 6, so that's 2 and 1. Okay, and then 2 goes into 14, so you end up getting 1/7. Okay, when you do all that. Now, if you're like, hey Matthew, I don't want to do that, I just want to multiply it. Well, you get 30 over, and then you got to know what 15 times 14 is. Okay.
Okay.
which, maybe maybe you don't. Okay. And let's say that this one actually works out kind of nice. See how the zeros cancel?
Oh yeah, I'm gonna stir over 21.
And then for the both divisible by 3. So you get the same answer, your choice, but be aware you do have to reduce. So that's one advantage of just throwing it into a calculator is you just get a number and then you move on. Whereas with a fraction, you got to simplify.
Okay.
All right. So next question, same scenario, but this time you replace. So that was we were starting out with 5 blue, 6 yellow, and 4 green. Okay, so this time though you're getting a green marble. So what's the probability of getting a green marble? It's the number of green
Divided by other ones.
by the total. The total includes the green though, because it's the total is everything.
Oh, okay.
So there are how many greens?
There's wait, how many greens there? 6.
Yes. Are you reading the same problem I am? A jar contains.
A jar contains. Wait, oh, green 4. Sorry,
4 green. Okay.
I was looking at yellow.
4 green.
Yep.
And then the total is the same. What is the total number of marbles?
The total number of marbles is 15.
It's 15. Yep. Okay. Times. Okay. We can talk about why it's times, but for now, let's just go with it. In this scenario, you're replacing it. You take the green out, but then you put it back in. Great. So your total does not change this time because when you take one out, you put it back in. Your new total is still 15 because you put the marble back in.
Okay.
But now we want blue. So what's the number of blue?
There are 5 blue markers. Marbles.
Perfect. Okay. Okay. So again, like this is it. Now you could multiply.
Yeah.
That's totally fine. There's benefit to reducing this way. This ends up being 4 over 45. Then you'll get the same answer when you do all that. All right. Is there anything that you would like to do another problem like, or should we just move on to the next?
We can move on to the next. Yeah, that'd be fine.
Okay. Any of this interesting to you or not? Total boredom?
No, I mean, it's fine. I mean, I got to
Okay.
do it anyway, so.
Well, yeah, you got to do it, but like, does this, because if you're interested, like there's a lot of stuff that you might already be doing that is based on this. Like it's not this, but like if you're following college basketball, there's tons of probability and statistics stuff going on there.
Yeah, that's true. The brackets and stuff.
Bracket stuff, exactly. So like, I'm not saying this is interesting, but maybe like, oh yeah, I kind of like it's different part of
Yeah,
math
I
that
mean,
I've
I'm
not
interested
thought
in
about.
stuff like that, but
Yeah, but then we got to do this, to get
yeah,
to it.
I just got to do math. I just need to get the
Yeah.
good grades.
All right. Saki surveyed 100 students at his school. Okay. So what that means is that when whatever this number is right here, that's your sample, or like it's all the grouping that you surveyed. These 4 boxes are going to add up to 100.
Okay.
But so is this box down here, and you'll see why in a moment, but I don't want you to be surprised when this happens. So I'm going to delete that and we're going to carry on. Of the 60 students that like football. So here's the like football column. Do you see that?
Yeah, I do.
Like football right there. That total is 60.
Yeah.
It says 10 of them do not play a sport. Which of these values is 10? 10 of them do not play a sport.
Out of 60.
Which of these 2 cells is 10? It's not a guess. I'm just asking, like that one says plays a sport. The second one says does not play a sport. 10 of them do not play a sport. Where does 10 go? Does 10 go here? Or...
Play a sport.
right here.
Yeah.
Now these vertically have to add up to this total right here. So there's like a vertical total. There's also a row total.
Okay.
So what number goes here so that when it's added to 10, it adds up to 60?
50.
50, perfect, okay. All right, now it says 10 students who dislike football also play a sport. Okay, so where is the column that dislikes football? Right here,
Right in the middle.
okay. 10 play a sport.
Yeah.
Does 10 go here or here?
Where?
You got this cell or this cell? Does 10 go here or here?
Oh, that cell right there. I mean,
Give me
yeah, the top.
the top one there. Great. Okay. Now, because there's so many ways to do this, but because the total is 100, 60 plus some number has to equal 100.
Yeah, it is.
And that's 40. Okay. 10 plus some number has to equal 40. Well, that's 30. Does 50 plus 10 plus 10 plus 30 equal 100?
Does 50 plus
10 plus 10 plus 30, does that equal 100?
yes.
It does. These equal 100. And then if you go horizontally, what is 50 plus 10? Well, that's 60. What is 10 plus 30? Well, that's 40.
40.
Does 60 plus 40 equal 100?
100. Yep. So it all lines up.
It all lines up. And you cannot go on before you do this.
Okay.
You know, this is like trying to drive with your doors open, your hood up. Like you got to get this right before you do anything else.
Yeah, I get it.
Okay. So we're going to refer back to this over and over and over again.
Okay.
So please get these down
Okay, just
for the next few questions. So,
okay.
All right. So we filled out the table. That's part A. All right. Now we're going to answer some questions. So some of the questions are straight, just counting questions. And that's this first one right here. It says, how many students surveyed like football? And the answer is 60. How do I know? Because it's this first column.
Yeah.
And the total is 60.
Mm-hmm.
How many students do not play a sport? So usually these are either referring to a row or a column. So in this case, it's referring to a row. Rows are horizontal. So it's referring to do not play a sport. It's referring to, let me show that here. It's referring to this right here.
70.
The do not play a sport. So that's, I'm looking at the 10 plus 30. The 40 is the total.
Oh, okay.
That's another point, I guess, is like sometimes they give you a total, sometimes they just give you the data. So sometimes you have to actually go in and make the total.
Oh, yeah, that's true.
All right, so now, part D. Wow, I don't like the way they're doing that. So part D. Part D says they want the relative frequency by column.
Yeah.
Okay, so here's what that means. And column does matter. So for plays a sport, 50 out of 60. Because your total is 60, and that's because it's a column total. Columns go that way, rows go that way.
Yeah.
And so you got to get a decimal for that. It doesn't say how many decimal places. This one doesn't round. Great. 0.83 on that. Does not play a sport. That's 10 out of 60, which is 0.17. And then we got to do the same thing in the next column here. So the next column is 10 out of 40. I'm taking that 10 over the 40. That's 0.25. And then the next one is 30 out of 40, which is 0.75. right, I'm snipping in question E.
Okay. Is there an association between playing a sport like in football?
So let me try to let me grab this table and bring it down, and we'll try to answer it. Okay, so there are people that like football. Okay, and there are people that play a sport.
Yeah.
And so the like the question is like, and this is somewhat vague. There's an answer to this, but I don't know if I really don't know exactly what your instructor wants here. But it's like if you like football, does that mean you play a sport? Well, not
Yeah.
necessarily. Like 10
Honestly,
people, yeah.
I know a lot of people that just like watching sports, but they don't like doing them.
Exactly, and that may be what's going on here.
Yeah.
It's also possible that you don't play a sport and you don't like football.
Yeah, that's true.
Like that, like there's like 4 possibilities. Like football, play a sport. Like football, do not play a sport. Play a sport and dislike football, do not play a sport and dislike football. And that's kind of what they're asking here. They're asking for the probability. This is probably beyond what you're looking for here. Sport and like football. So the probability of this is 50 over 100, because there's 50 people that like the sport and like football,
Yeah.
which is 1/2 or 0.5. Okay.
Mhm.
Now the probability of liking football, and this is where it's probably more complicated, is it's 60 over 100, which is 0.6. And the probability that you play a sport is 60 out of 100. Again, it's this number up here, 0.6. So if you multiply these two numbers, 0.6 times 0.6, you do not get this number right here.
Okay.
And why does that matter? It really doesn't to you. I really don't know what your instructor wants here. I would probably wouldn't put anything down that I just wrote. I would probably say that what you said in words, which is that like there are people that like football
Yeah.
that don't play. They just like watching,
Mhm.
and leave it at that.
Okay. Just so like I don't get marked down for it or whatever, just in case.
Yes.
All right, I'm ready to move on.
Great. So question 4A, it says to draw, and really what they mean is they want you to write something down that explains the outcomes.
Okay.
So what I mean, and they don't actually mean to draw a pancake, although that does sound pretty good at the moment. And we got maple, blueberry, or strawberry. So for example, for you, and you know this because you've had breakfast before, like you get a pancake or a waffle, but maple syrup goes on top. So for example, PM means pancake with maple syrup.
Okay.
But you could also get a pancake with blueberry syrup, or you can get a pancake with strawberry syrup.
Yeah.
And what we are creating here is the sample space, all these options. So the next one is waffle with maple syrup, waffle with blueberry, waffle with strawberry. Now notice I excluded PW. What would PW mean in this case?
PW is pancakes and
waffles.
waffles. Yeah.
So we're assuming that you get like one carb and one sugar.
Yeah.
like that's out. We're also saying MB is out
Yeah.
because nobody goes and just says, yeah, him put maple syrup in a cup and then put blueberry syrup in the same cup and I'm going to drink it or whatever.
Mhm.
So there's a little bit more that's needed, but this is your sample space. I mean, these are the 6 options. 1, 2, 3, 4, 5, 6. These are the 6 options that you have. And you actually probably do this in some ways in some other part of your life. Like you might say, oh, I got to wear that shirt. And does this, or this go with that shirt? And then you make a decision. Okay, so part B is the probability of pancakes and maple syrup.
Yeah.
So we want the total. The total is 6. 1, 2, 3, 4, 5, 6 options. And then how many options are pancakes and maple syrup? Means they have to both be true. Well, PM, that's 1. Is there any others that are pancakes and maple syrup? Just having maple syrup is not okay.
No.
So just the 1. And that's okay. That's just what it happens to be.
Yeah.
We should have done D first. We'll do D next.
Okay.
So this time it's probably a strawberry syrup. So again, it's the total over the number of strawberry syrup.
Yeah.
So how many of these up here have strawberry syrup? How many of them have an S in the second position?
How many have an S? One, just one? I think. Wait, I'm confused.
Well, there's 2 letters here. Strawberry syrup means it's an S in the second position.
Yeah.
So does PM have an S in the second position?
PM.
Is there an S here?
No.
Okay, PB, is there an S?
No.
PS.
No. Yes.
Okay, so that's 1. WM, is there an S?
No.
WB.
No. So okay, there's 2. Oh my
There's
gosh.
2. And what's the total again?
2. Wait, 2, I don't know.
Total means all possibilities.
Then W. Or, I don't even know.
Well, how many are here in the curly brace?
How many? Wait, where? I don't know what I'm doing right now. I'm like,
Well, I'll wait. Let's take 2 minutes and you can just refresh. We're almost through. And we'll just take 2-minute break here.
okay. Okay, I think I should be fine now.
All right, I'm back. Remy, let me know when you're ready.
Okay. Yeah, I'm good. I'm ready now.
Okay. So what does PM stand for up here?
Pancakes and maple syrup.
Great. And what about PB?
Pancakes and blueberry syrup.
Okay. And then we continued this pattern. This is the sample space. This means all the possible outcomes. How many possible outcomes are there?
6.
There's 6. There's 6 possible outcomes. That's your total. Okay. Your total is almost always the same in every problem that you do. We showed the total of 6 here. There's a total of 6 here. Now you might be thinking it's the total number of strawberries, but it's not. The on top, it's the number. The number is what you like want, not the total possible. And I don't think it's a great description, but we just have to kind of go with that for the moment here.
Okay.
All right. So let's go with part C. Part C here. Let's see if we can take a look at that. All right, and this is not, a so-called trick question. We don't have to read this. What is the total?
The total is wait, can you scroll up really quick? 1/3 or 1/6.
Let's go back. The sample space is all the possible outcomes. How many possible outcomes are there?
6.
6. The total is the number of possible outcomes.
Oh, so 6.
Yes. Okay. Now we go find the ones we want. The ones we want have to either have a W in it or a B in it.
Yeah.
So let's go back and look, and we're just counting. Does this first one have a W or a B in it? Hey, Remy.
Hey, sorry for my computer died.
All right, no problem. So we got the last question here. Waffles or blueberry, and I was trying to say it's either got to have a W or a B, and we're just counting. So we're just going to go back and look. Does PM, does it have a W or a B?
No.
Nope, but PB does. So we count.
Yeah.
We say, okay, there's 1.
So there's
How about the next one?
no.
Nope, but each of these do. So
Yeah,
there's
they are.
so that's 1 plus 2 plus that's 1, 2, 3, 4, 4 of those. So that's 4 over 6 reduces to 2/3.
Yep.
All right. So did you get all of that down on your
Yes.
paper? Great.
Yes, we got most
Excellent.
of that down, yeah.
Okay, perfect. So we have a few minutes left. If you would like to use it, we can probably cover another question or two. It's totally up to you. Please
we could cover like one more question. That would be fun.
All right.
Fun. Yeah.
Okay, so let's make a little table here, and let's say that 10, 12, 18, and 10, and this one is male, female, dog, cat. Okay, So I want you to fill in the totals for me, or you can verbally tell me in each position what the totals should be. Start with that.
Okay, so the totals are 22, right?
Okay.
And then 28.
Okay. What about over here on the right?
28 and 22.
Okay. And then what's this last one here?
Then that's 50.
50. All right. So what is the probability of a dog according to this? Probability of dog. So it's the
22.
number of dogs over the total, like the big total.
Yeah. The
Is that
22.
over?
I'm not sure.
What's the total? What's the super total? Total of all the animals.
Oh, 50.
50. Yep. Perfect.
Okay.
What's the probability of being female?
It's 22.
Out of?
50.
Perfect. Okay. What's the probability that you're a male dog?
28 over 50.
There are 28 male dogs in this cell chart here. That's what you just said. You said there's 28 male dogs, but there's only one intersection of the two. So if you're a dog and you're male, that's this number right here. So maybe that wasn't made clear. If you're in this cell, top left here, you're a male dog. Yes, no, maybe. If you're speaking, I can't hear you.